In this video, we're going to find the mass of this triangular plate. Now you can think of this triangular plate as being a piece of metal. And if this plate had constant density, then its mass would equal density times its area. But as you can see, the density is variable. So we have our density function. Density, we'll use this symbol rho for density. And you can see that our density function is variable. It varies as x varies. So because our density varies, we need to use an integral. So the mass is integral. So the general formula, mass is the integral from a to b of rho, the density function, times dA. And in our case, we see that our density function is in terms of x, so it makes sense that we'll integrate along the x-axis. So you can see the triangular plates. Let's see, our bounds are going to be from 0 to wherever our triangular plate stops. X plus y equals 4 has x and y intercepts at 4. So if integrating from x equals 0 to x equals 4, so our mass is equal to 0 to 4. We'll just put in our mass function, 17.4 minus 0.3x squared times dA. And so now we need to find dA. Now to find dA, what we want to do is draw some rectangle. Let's just pick a point. We'll draw our vertical rectangle there. Remember, dx is the width. So we'll have a dx. So we'll have something for our length, right? We're going to have our length, and our width is dx. So dx is our width, and our length is how far we go up for our rectangle there. Now, since we have the top of the rectangle is at x plus y equals 4, we're looking for a function of x, so y equals 4 minus x. So our height, y, is 4 minus x. So that'll be our length. And so there's our formula with all the necessary pieces, and then we can compute the integral. I won't compute the entire integral, but let me just simplify it out just a little bit to where you would be able to take it from there. So continuing on, I have 0 to 4. And so now I'm going to use the distributive property, distribute 17.4 to 4 and negative x, and then add that to negative 0.3x squared, distributed to 4 and negative x. So doing that math, let's see. There, I get 69.6 minus 17.4x. Doing this math here, I get minus 1.2x squared plus 0.3x cubed dx. And then if you take the antiderivative and evaluate at the endpoints, your final answer will be 132.8. And the units are grams. So the reason the units are grams there is, notice my units for my density function are grams per meter squared. And so the idea here is if x and y are in, so they're grams per meter squared, so x and y are in meters, right? X meters, y meters. And if you think about it, right, dA, right, dA is going to be meters squared. So the units on dA are going to be meters squared. And the units on rho are grams per meter squared. So grams per meter squared times meters squared is going to be grams. So that's why our final answer, the units are grams. So let's see, what did we get again? 132.8 grams.